We get to do hyperbolas today. I'm going to pretend it's a great privilege because they're probably the trickiest ones for students because there's a lot of stuff going on. But the use for these, it talks about lightning detection, uses multiple sensors to digitize lightning strike waveforms and record details. It says 2 sensors detect a signal at slightly different times and generate a point on a hyperbola where the distance from each sensor is proportional to the difference in the time. Okay, so I don't really get all that, but this is a hyperbola. It has 2 branches, and there's going to be a focal point here and a focal point here. And I'll show you the fancy definition in a second. But the question I usually have is, what is the difference between the shape of a hyperbola and a parabola? Okay, so I tried to check it out. I didn't get a really good answer. This is a parabola, okay, and this is a set, it's a hyperbola, but it's both branches. The difference with this is that there are asymptotes. I can't draw them accurately, but there are asymptotes in here, and it will never go past those. With a parabola, it gets infinitely wider. Okay. Yeah, I shouldn't have drawn on there. There's a fancy definition down here. It says, when a set of points are equidistant from a directrix and a focus, then it's a parabola. This is the definition today. When the difference of the distance between points in a plane to 2 fixed foci is a constant, it's a hyperbola. Yeah, that didn't really help me out either. This is the fancy definition. The absolute value of the differences of the distance from 2 foci is a constant. Remember the parabola definition was all the points the same distance away from this focus as they are from this directrix. These were equal. Trying to remember that. And then on an ellipse, it was the string thing. The string stayed the same length. If you added this and y together, it was always the same no matter where you were at. You could be over here, and if you had a string that went like this, whatever that x and y are, it stays the same all the way around. Well, this one is real wonky, and it's hard for me to understand. But if you measured from any point on the hyperbola to both foci, and then you subtracted that difference, it stays the same all the time. Okay, good to know, but that's not going to help us. We have to be able to graph these, find the center, vertices, foci, and asymptotes. That's the new thing today. And we have to be able to complete the square, write an equation, and find the eccentricity. We're not going to get to all of that today. All right, there's 2 vocabulary that they talk about that honestly I don't use much. Okay, the transverse axis is the axis like a line of symmetry through them this way. It goes actually through the 2 blue hyperbola. The conjugate axis is perpendicular to that. It's also a line of symmetry, but it doesn't actually touch the hyperbola. And I'm not going to use that vocabulary much. So I'll show you in a second. But first, let's look at these equations. What's different? This is very much like an ellipse. Can you tell what's different from an ellipse? Hear me through that first part. Sorry about the fan. What's the difference between this and an ellipse? Yes, in here it is subtraction. Okay. When you subtract, does order matter? Yes, very much. So, guys, this is what I need you to see. When in front of the subtraction is the x, then the a squared is going to be underneath there, and it's going to open left and right. Okay? When what's in front of the minus is the y, the a squared is underneath there, and it's going to open up and down. A squared can be bigger or smaller than b squared. It doesn't matter. What does it say on your reference sheet? I wrote you a little note there. What does it say? A is under the positive term and B is under the negative term. Do you see what I'm talking about here? A is always underneath here and B is underneath the minus one. Okay, so the difference between these two is this one had an x quantity and then a minus y quantity, so it opened sideways. This one had a y quantity minus an x quantity. It opens up and down. Okay, this could be 12 squared and 3 squared, or it could be 6 squared and 27 squared. Okay, A can be bigger or smaller. It doesn't matter. So do you understand that there's a difference in how you decide where A is on these than the ellipse? Because your recipes are going to be all wrong if you use the wrong thing for A and B, right? All right, so here's all the recipes. They're down here, and we are not going to use these ones, transverse and conjugate, okay? But you are going to have to write the asymptotes, and you can leave them in this form. I'm not going to make you do anything with it. We're just going to plug in H, K, B, and A, and then leave them like that, okay? So let's get to talking about what this thing even is. What a hyperbola is you pretend you're drawing an ellipse, but instead of the oval, you put a rectangle in there. And then you draw in the diagonals, and that rectangle is called the auxiliary rectangle, and you have to draw it, guys. Always get people who think, oh, I'm just going to skip that step. Well, then their asymptotes aren't accurate. If you want a ruler to do today's stuff, you are more than welcome to grab one off the wall over there by the cookies. All right, you don't have this one, so I'm just going to show you real quick what a hyperbola looks like and does. This one is centered at 0, 0. Does everybody see that? There's no H and K up here on top. What is A and what is B? Can you tell? Yeah. A is 3 and B is 5 because the A is underneath the positive term, not the bigger number anymore. Now, it has a y squared that's positive and then minus x squared. Which way is it going to open then? Yep. I just spent a whole bunch of time on this. Y squared be bigger. This be a bigger number, you mean, or? No. Okay. When the y squared is positive, it's going to open up and down. A is 3 and B is 5. The center was at 0, 0. So what's going to happen is because these go together, from the 0, 0, I'm going to go up and down 3. Everybody good? Y direction 3. Y direction 3. Y direction 3. Okay. X, underneath the X, I'm going in the X direction 5. Then I draw that rectangle. Then what I have to do is put in the asymptotes, the diagonals, and those will make the asymptotes. Okay, that one wasn't too bad. Yeah, that one's not close. Let's see if I can just... All right, you see what I'm saying? They have to go corner to corner. You all right? Now, once you have that drawn, then the actual hyperbola, this one says y came first, so it's going to open up and down. So the edge of the box is your vertex, and it goes up and down, so it gets closer and closer to those asymptotes, up and down. if the x squared had been first, I would have drawn it in these spaces sideways. Okay? And then you would find the foci. How do you find C this time, guys? Look at the recipe, it's different. It's a squared plus b squared. So this would be 9 plus 25 is 34. So yes, it's square root of 34. The reason it's not minus, because minus would put your foci inside the box, and we need them to be outside of the box, inside of the curvature of the hyperbola. Square root of 34 is almost 6, so the foci would be up here and down here. Okay? Then the equations of the asymptotes, what point do they go through? 0, 0, right? Do you remember this equation of a line? Called point slope. That's what we're going to use. We're going to say this one goes through 0, 0. And then the slopes, guys, are either a over b or b over a. That's it. But the difference is it's got to be change in y over change in x. How much did we go on the y and how much did we go on the x? 3 and 5, right? So this is me plus or minus 3/5. And you're done. You don't have to write anything else for those. You don't have to mess with them. Okay, so let's try this one. You have this problem. Which way is this one going to open? Up. It's the example. Y squared minus 16 y squared over 16 minus x squared over 4 equals 1. Find it? Yeah. So it goes up and down along the y4. It's still centered at 0, 0. It goes side to side across the x, 2, because that's 4 squared is 2. So we get a little narrow rectangle in here. Like this. Any questions about where I got those numbers? So A was 4 and B was 2. And because it had a y squared, it's going to open up and down. Okay, then you draw in the asymptotes. Make sure you're following. If the slope is up 2 and over 1 to get to that corner, keep going up 2 and over 1. Okay. Now, where am I going to draw the actual hyperbola? Up, top, and bottom, or left and right? Yes, because the y squared was first, they go top and bottom. So they look like this. The vertex is the very top of the middle of the box there. That's part of the hyperbola. And then this is the rest of the hyperbola down here. Okay, mine are very pointy. They're not supposed to be very pointy. Sorry. All right, so where was the center for this question? It was just at 0, 0. All right. It says we should find the vertices. Well, the vertices were at the top and bottom of the box, which we went up and down how much? Do you remember? 4. So if we put a 0, 0, and the a value of 4 in here, we'd have 0 and then 0. Yeah. So we have 0, 4, and 0, negative 4. All right. The foci, we need C. So a squared plus b squared equals c squared. A squared was 16, b squared was 4. So c squared is 20, or c is the square root of 20. 2 square roots of 5. So guess what? Because it's an ugly radical, you can just leave it in that form. So it's going to be 0, and then 0 plus or minus 2 square roots of 5. So they are at this. You can just leave it. You don't have to write them out separately. What is the square root of 20, guys? A little bit more than 4. So if we go up a little bit more than 4, it's just inside of here. And that again has to do with the fact that these two are really narrow. So the foci is really close to the vertex. Remember that was true of an ellipse as well. If we go back to this question, the foci was a lot further in and they turned out to be very wide open. Just something you might remember. All right, what's our center again? 0, 0. So we have y minus 0 equals plus or minus, and then back here we have an x minus 0. And then we have to put in the slope, and the slope is either a over b or b over a, depending which way it opens. What's underneath the y goes on top. So a over b would be 4 over 2, or 2 over 1. Is that what we were doing, guys? Did we go in our little box here up 2 over 1? Right? The slope right there was up 2 and over 1. If we'd gone down, we'd go down 2 and over 1 to get this other one. And I'm just going to let you leave it like that. Not too bad? Okay, all that's going to change is the center isn't going to be 0, 0 anymore. So it's a little more work. Oh, we have one more that's 0, 0. Oh, what's different? We can do this one real fast. Yeah, the x is first, so it's going to open left and right. Is a 6? No, a is 5. Okay. H and K are still 0. A is 5 because a squared is 25. B is 6 because b squared is 36. C would be the square root of a squared plus b squared, which is going to be the square root of 61. All right. We can do it conceptually, or we can just follow all the recipes. Okay. So what does it say for the center? That's not too tricky. This one's just 0, 0. Okay. Now, which one are you looking at on here? Left one or the right one? Do you have your stuff, Alexa? Can you, like, at least get out the reference sheet so you know where we're looking? Really be great if you took a couple notes at least. The left one, because the X came first, okay? So it's the one on the left side of the reference sheet. Yep, can't read that word, but anyway. All right, so the vertices are at plus or minus a, comma, k. So that would be negative 5, 0 and positive 5, 0. We wanted to do by recipe, so we're just doing it by recipe. Okay. The problem is, if all you follow is the recipe, you're not going to know how to draw the rectangle. How do we find the top and bottom of the box? Oh, the B values, right? We went out 5 left and right, so we have to go up and down 6. So 2, 4, 6, 2, 4, 6. It's almost a square, right? So draw your auxiliary rectangle. Maybe students don't draw it because it's not on the, it's not drawn for us on the reference sheet, right? But I'm telling you, you got to draw it or you're not, and I put it in the directions on the quiz, or you're not going to get full points because you're not going to draw the hyperbola accurately if you don't draw the asymptotes. Okay. It's either A over B or B over A. What does it say on your sheet? It says y minus k equals plus or minus, for one that opens this way, B over A. Okay, what was B? Didn't we go up 6 to the top of that and over 5 here? So it's going to be y minus 0 equals plus or minus 6/5 x minus 0, or just plus or minus 6/5 x. These were the vertices, remember? So which way is this going? Yeah, so we're drawing them in here. They touch the box at only that one point, and otherwise they follow along the shape of our asymptotes. Supposed to be without touching them. What did we miss? Just the foci? Okay, what's the recipe for foci when it's going sideways? H plus or minus C, which was square root of 61, comma, K. So the foci are just at plus or minus square root of 61, 0, which would be almost 8. So they're way in here, close to 8. They have to be inside of the curvature of the hyperbola. All right. We're masters, so now we're moving on to ones that aren't centered at the origin anymore.
Okay.
We got this?
Yes.
Okay, so what's H and K? And this is easy to get wrong right off the bat.
Okay.
Yes, this is H and this is K, because the H is always with the X and the K is always with the Y. So I'm going to make a little list over here. H is -2, K is 3. So the center is at -2, 3. What else do we know? Which is A and which is B?
A is 25.
Yes, A is always under the positive one. Doesn't matter if it's bigger or smaller. So A squared is 25, which makes A 5. B squared is 9, so B is 3. All right, so if we go left 2 and up 3 on this counting by 2 graph paper, there's our center. Which way do I go, left and right?
No.
Okay, the 5 tells us to go up and down, right? That's going to be the vertices. So 2, 4, 5 is right here. 2, 4, 5. I don't know. Let's double check that by using the recipe. Where are the vertices? What's the recipe for vertices when the Y comes first? All right, so we have -2, 3, plus or minus 5. What do those become? Because you have to write them out when it's nice whole numbers.
Negative.
So -2, -2. Oh, I totally plotted that one wrong. That's because I didn't count. Weren't we supposed to be going up and down 5? Yeah, I was. Okay. Is that one right?
Yeah.
All right. -2, -2 is here. So then this was up 1, 2, 3, 4, 5. So that's -2, 8. That one's right. Okay, thanks. Sorry. So those are the vertices. Now, how much are we going out each way? 3. And that's a part, if you skip this and just try to draw this in, you're not going to get it right. You got to draw the box. You're going to go 1, 2, 3, 1, 2, 3. Okay, now draw the rectangle. I'm going to see if I can cheat. There's the rectangle, right? And then I'm going to put in the asymptotes. See if I can adjust those a little. Should be going corner to corner and through the center. We good?
Yeah.
And which way does it actually open?
No.
So I draw it in up here. Don't forget to actually draw it, because all the rest of that is not actually the asymptote. It's just the guidance to find the asymptote, or to find the hyperbola. Sorry, I'm saying the wrong word. It's hyperbola. Right, Nolan? Okay. So what do we still have to find? Two things. Foci and asymptotes. Yep. Okay. So we need to find the C value. Good call. C equals the square root of a squared plus b squared. So we'll have the square root of 25 plus 9, 34. And then what's the equation for foci? When it's opening up and down, so that will be -2, comma 3 plus or minus the square root of 34. Now, if you want to know if you did it right, you real quick type 3 plus the square root of 34, and you get 8.8. So it would be at 8.8, just barely inside of there, right? So it was enough to put it inside. And then if you did 3 minus this, you should get it just inside down here. All right, asymptotes. Equation when it's opening up and down is y minus k equals plus or minus a over b x minus h. Guys, I can never remember if it's a over b or b over a. I just look up here and go, it's the one under the y over the one under the x because slope is y over x, yes? So it's always the what's under the y over the x. So it's going to be 5 over 3, which is what we had here for a and b, plus or minus 5/3. But we do need to put in a different center this time. What was k? It was just 3, right? So it's y minus 3 equals plus or minus 5/3, and then x minus k, which was the x plus 2, which is exactly what we had up here and up here. Not so bad. All right, so we got some practice on this and some practice on completing the square. What do you want to do? Just do another one of these, or you want to do completing the square and come back and do one of these? You know, try mix it up a little. Okay, when we are completing the square, remember if we end up with something squared plus something squared equals 1, it's an ellipse. If it's a difference, like something squared minus something squared equals 1, then it's a hyperbola. A circle would look like an ellipse, but both of those would be the same distance. So you'd end up with like no stretch and something over here that's the radius squared. And how do you know if it's a parabola? Yeah, only one of them is squared, whether it's the y or the x, but only one of them is squared. Okay, so we're supposed to figure out what this is. Number 16, how do you want to complete the square on this one? Okay, so can you do this one on your own? X squared minus 4x plus blank, y squared plus 6y plus blank equals -4. Finish that one up quick. Wow. Five people gone, and still half the people who are here aren't doing this? Half of 4 is -2, squared is 4. Half of +6 is +3, squared is 9. So I got 9 on the right. You can divide by 9 if you want, but what is this? Oh, I forgot a squared, yeah. Thanks. It would be because it's a plus, but does it stretch in either direction? No, so it's actually a circle. If you divided it all by 9, you'd realize you had a 9 under both, right? So it's going the same way, so it's a circle. Okay, 17. Talk me through this one real fast. Take a 9 out of the x squareds. What are the x squareds? Or the x's, sorry. I'm trying to skip a step here. X squared plus 54 divided by 9 is 6x. Okay. The y's 4, and then we'd have y squared plus, we divide it out of 4, we'd have 2y. Oh, man, I have no room. I wrote too big. Oh, my goodness, what did I just do? Plus blank equals, and then I'm going to move the 49 over, so don't forget to make it negative, and I need a couple blanks. Okay, what's everybody going to do? They're going to write x plus 3 squared 9, 9. Is that right?
No.
Why not? Yes, this 9 out here stays with us, and 9 times 9 means we're adding 81 to this side. And here we have 4. Y plus 1 squared is 1. 1 times 4 is 4. I have no idea what that comes out. I'm guessing 36. Okay. I'll tell you how I did that, because it had a 9 and 4 here, and I knew we were going to need to divide, so it was going to probably come out nice. I was just guessing. Okay, now we have an ellipse because it's plus in the middle, but it is stretching unevenly, right? 9 one way, 4 the other. So we have to divide everything by what?
36.
Yes. So we have x plus 3, quantity squared. 9 goes into 36 4 times. Y plus 1, quantity squared. 4 goes into 36 9 times, equals 1. I'm going to take a 60-second commercial break to review eccentricity. Does anybody remember what the formula was from yesterday? It's on the back of your sheet. E equals? Nice. And when you have an ellipse, A is always which one? The bigger one. So this is A squared, so A is just 3. Now, finding C is different when you have an ellipse. Do you remember the equation? A squared, which was 9, minus B squared, which was 4, so we get square root of 5. Somebody divide that out, give me a decimal. And by typing square root of 5 divided by 3. So 7.5 or 7.4, whatever. What does it say on your sheet? For an ellipse, it's supposed to be between? Okay, good call. All right, thank you for that commercial break. We're moving on, completing the square. This is, wait, that's another, this is another ellipse. I don't want to do this one. Is there a hyperbola one? Yes, I want to do 19. Let's look at 19. This is the hardest one for students to do because when we gather the x's, those are positive, right? Then we have a minus y squared plus 8y, and we're going to move that negative 112 over the other side. What do you think we're going to have to factor out of the x's? Okay, that wasn't too bad. 96 divided by 16 is 6. But here's where it gets tricky. What are we going to have to take out of the y's?
5.
Nope. We want a y squared in the parenthesis. Yes. Does everybody see what I'm talking about? We can only complete the square when we have 1 x squared or 1 y squared. So we need to take a negative 1 out of those. What does that do to the 8y? Minus 8y. Do you see where that gets a little tricky? And then over here we have a negative 112, and we're going to add a couple blanks. Okay, we're not done with the trickiness though, because when we go to add in those blanks, we got to remember that negative 1 out there. So this one is x plus 3 quantity squared, because we took half, squared it, and we get 9. So what are we putting over here? Whatever 16 times 9 is, right? Did I lose anybody? Right here? Okay, but what happens back here? This is the one I'm worried about. Minus 1. Half of minus 8 is minus 4. Squared is 16. But
Negative.
yes, I actually put a negative because of this negative 1 times 16. I'm actually doing a negative 16 over there. Okay, so someone help me. Negative 112 plus 16 times 9 minus 1 times 16. It is just 16. Okay. So then we divide everything by 16. And we'll have x plus 3 quantity squared over,
No.
yeah, we could put a 1 there just to help us remember what's going on, minus y minus 4 squared over 1 goes into 16. There's still a 16 down there, and on the right we have 1. It is a hyperbola that opens which way? Yes, because of the x being squared, it would open this way. All right, and we're going to do eccentricity tomorrow or Monday, but eccentricity is still going to be c over a for these. It's just going to turn out greater than 1. All right, let's go back and graph one more. Do we have 2 to choose from or just 1? Number 3? Okay, let's practice one more on number 3. I think that's it anyway, right? Yeah. Okay. Number 3. What can you tell me? A is 4. Is that correct, guys?
Yeah.
Yep. A squared is under the positive, B squared is under the minus term. So B is 6. This is number 3?
But I'm 7.
Yep.
Oh,
What else? You told me something about H and K. Okay. So 1, negative 2. Why can't we get some normal graph paper? All right. You want to find the vertices next, or you want to just make the rectangle because we're smart like that? Okay. So we're smart, and it says under the X, we should go out how far? 4 either way in the X direction, which is left and right. 1, 2, 3, 4. Remember, we're counting by 2s, so it's half a box. 1, 2, 3, 4. And we can double check that when we find the vertices in a minute. Up and down, though, we're supposed to go how far? So that would be 3 whole boxes up and down. Okay. Make your rectangle. Draw in your diagonals. Welcome to use rulers. Not that you have to be 100% accurate, but okay, then what? Which way we draw on this hyperbola? Because the x was the positive, but then it was minus the y squared back here, that tells us it's opening around the x this way. Wow, that was really badly drawn. All right, so the blanks on the quiz will say center, we already did, and then it'll say vertices, foci, and asymptotes for this one. So what's the recipe for vertices? When it's opening left and right, so we have 1 plus or minus 4 comma negative 2, which would be 5 negative 2, and 1 minus 4 would be negative 3 negative 2. Is that where we have them? 5 negative 2 and negative 3 negative 2. We're good, right? It's your check. Is it working here? They should be where we hit the box there. Okay, we need C to be able to find the foci. And c is the square root of, yep, 16 plus 36. 4 goes in there though. What is that? 2 square roots of 13? Honestly, I would be okay if you left it square root of 52 for this. I don't care. Okay. So the foci are at, when it opens sideways, h plus or minus c comma k, which would be 1 plus or minus the square root of 52. I'm going to let you go with that. Comma, what's k? Yeah. So, guys, conceptually, anybody listening? The square root of 52 is how far you go from the center to the foci. So it's a little over 7. So 1, 2, 3, 4, 5, 6, 7. Somebody do 1 plus the square root of 52 and tell me what you get. Is it close to 8? Okay, so I was right. It's in here a little bit. All right, and then you would go this way, and 1 minus the square root of 52 would have you over here somewhere. Okay, those are the foci. Asymptotes, almost done. It goes y minus, yeah, y minus negative 2 or plus 2. Now, is it going to be b over a? Look up here. Don't look at your sheet for me for a second.
Okay.
Which one's underneath the y? Yes. So it's 6 over 4 or 3/2. You can at least reduce the 6 over 4, right? And then it's x minus h, which is minus 1. Does it seem right if we go, didn't we go up 6 and over 4 when we made our box? So that's 3/2. Not that bad, yes. Just remember to draw that rectangle. I think we're pretty good at this. Do you want to do the one more completing the square, or you're good? Okay, I'm fine with that. I don't know if I have this right, though. Can someone, I feel like some number is wrong here. 6, oh, it's not 9, it's 10. 6, 10, 15, 16, and 19. Okay. 5 questions. That's it. 5. You can do this. Guys, more Hyperbolas Monday, review Tuesday, quiz Wednesday. Is quarter today? Yeah. Yeah, today's the end of the quarter. Okay.